Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 3.5 entitled More on Linear Equations. And what we're going to do today is we're going to review solving multi-step equations that have variables on both sides of the equal sign and have to have distribution as part of the problem solving steps. So we're going to review those steps that we've gone over in previous lessons as to how to solve multi-step equations. And just like our objective said, our very first step that we're going to want to do is to distribute, if we have any distribution to do. So if we see a number that's outside of the parentheses, like 3 times, and then on the inside of the parentheses you have a couple of terms, you want to simplify that first. Okay. We also might need to simplify any sign changes, like if we had a 3 minus a negative 7x, we would want to change that to a plus a negative x, or plus a positive x. So that's not really distribution, but we are wanting to simplify any of those steps as well before we start our next step, which is to combine like terms. And remember, we're going to do this on both sides of the equation. So we're going to combine any like terms on the right side of the equation and then on the left side of the equation. And then we're going to have to move the terms all to the same side. Okay? So I'm going to say that we're going to do this on both sides, and then we have to move all of the variables and all of the numbers to one side. So it's kind of a two-step process for combining like terms. But by the time we do that, then we'll have a one or a two-step equation that we can solve. So then we will undo any addition or subtraction that's left over, and then we will undo any multiplication or division that's left over. Okay, so we have gone through all of these steps in previous lessons. Now we're just going to practice them in big, elaborate problems. And we're just going to take them a step at a time. So example 1 here has 3 parts to it. It has an A and a B and a C. It says to solve the multi-step equation. So the directions even tell us that we're going to have a lot of steps that we have to do here. And yes, we do want to show all of our work. So in part A here, we have negative 2 times 3x plus 5 equals 6 times 4x minus 5. So I have 2 sets of parentheses. I have a number out front of each of those parentheses. So right away when I look at this, I should think I have to distribute. So on the left side, I'm going to distribute the negative 2 to each term in the parentheses. So that'll get me a negative 6x minus 10. Then on the right side of the parentheses, I'm going to distribute the 6 to both of the terms inside the parentheses. So that'll get me a 24x minus 30. So we've done our first step with distribution. Now I'm going to look at the right side of my equation and see if I have any like terms to combine together. And I don't. I'm also going to look at the left side, see if I have any like terms to combine together. And I don't. Okay, so I get to skip that first part of the combining like terms, but now I have to do the second part of that, where I have to move all my variables to one side and all my numbers to the other. Okay, and again, we want to look and see which of these x terms is the smallest. And the smallest one is the negative 6. So I'm going to undo him. I'm going to add him to the other side. So what I do to one side, I have to do to the other. Put plus 6x and plus 6x. So the 6 and the minus 6x, they cancel. I'm just left with a negative 10 on that left side. 24 plus 6, that's going to be 30x minus 30. Okay, so now you could look at this a couple of different ways. You could say, oh, now it's a two-step equation that I have to solve. Or you could think of it as, I have all my variables on the right side. Now I have to get all the numbers over to the left side. So this minus 30 now, I'm going to undo that subtraction with addition so that I can move him over to the other side that has the other number, the negative 10. So now negative 10 plus 30 is going to be 20. And then I bring down the 30x, didn't do anything to him. And the minus 30 and plus 30, they cancel. So now my last step then is to finish isolating that x so I can solve this equation for x. He's being multiplied by a 30, so I'm going to undo that by dividing by 30. So then my final answer is going to be 2/3. When I reduce 20 over 30, that reduces down to 2/3. And those 30s cancel there. And I can leave my answer as a fraction. That's okay. 2/3 is as reduced as it can get. If you wrote that as a decimal, you'd get a repeating decimal, so it's actually a little bit better to leave him as a fraction. Okay, in part B, we're going to distribute again. You can see that I, again, have two sets of parentheses. So I'll have to distribute the 3 to the 2 and the negative x. And then I'll have to distribute the negative 4 to the x and the positive 3. But I also have this plus 5 in here. Now I'm not going to distribute the 3 to the plus 5 because it's not inside the parentheses. But after I distribute, I'm going to have to combine some like terms together. Okay, so let's start by distributing the 3. So I'll have 6 minus 3x. And then I'll bring down that plus 5x. Now there you can see I have two like terms on my left side of my equation. I'm going to have to combine them together after I do my other distribution. So I'm going to distribute the negative 4. So I'll have negative 4x minus 12. Now again, on the left side of this equation, I have two x terms that I can combine together. And since they're on the same side of the equation, I'm just going to do what it says. I have a negative 3x plus 5x, so that'll get me a positive 2x. And then on the right side of the equation, I don't have any like terms to combine together, so I'm just going to rewrite it. Okay, now again, I'm at that step where I have to get all my variables on one side and all my numbers on the other. So the smallest variable is my negative 4x, so I'm going to undo him. I'm going to do the opposite of subtracting 4x, which is adding 4x. So that'll move him to the left side of the equation. So now I'll have 6 plus 6x equals, and the 4's cancel, and I'm left with my negative 12. Don't forget that minus in front of the 12. Bring him down as a negative. Okay, now again, you can think of this in two different ways. You can think of it as, oh, I have a two-step equation I have to solve, or think of it as I have to finish getting all my numbers over to the right side of the equation. So the number that's on the left is this 6. He's a positive 6, so I'm going to undo that by subtracting. Okay, and I'll write the rest of the work over here since I'm running out of room. So the 6 and the minus 6, they cancel, but I still have my 6x on the left side of the equation equals, let's see, a negative 12 minus 6, that's going to be a negative 18. And now to finish isolating the x, I have to undo that multiplying by 6, so I'm going to divide by 6. So the 6's cancel, and x equals negative 3. Now again, I could check my answer. I could substitute the negative 3 back into the original problem where the x is. Okay, if I did that, I would have 3 times 2 minus a negative 3 is plus 3, plus a 5 times a negative 3 equals negative 4 times a negative 3 plus a 3. Okay, now it's like order of operations to simplify it here. Let's see, I'd have a 2 plus 3, which is a 5, and a 5 times 3 is a 15, and 5 times negative 3 is minus 15. So that would get me a 0. And then on the right side of the equation, let's see, negative 3 plus 3 in parentheses, that's 0. And negative 4 times 0 is 0. So I would get 0 equals 0. So that's a true statement. So again, I know I got the right answer. So that's a good idea and a good strategy to check your work, especially for these big equations. Okay, now part C, don't be intimidated by that fraction, okay? This fraction is outside the parentheses. This 1/3 is outside the parentheses. And when we have something outside the parentheses, we want to see if we can distribute it. So let's look at the numbers we'd have to distribute it to. We'd have a 21x and an 18. Remember, multiplying by 1/3 is kind of like dividing by 3. So can I divide 21 by 3? Yes, I can. Can I divide 18 by 3? Yes, I can, and they'll divide evenly. So when I distribute this 1/3, I don't have to be afraid of getting fractions. I'm going to end up getting whole numbers. So it's okay to distribute this fraction. This one is actually going to work out nicely. So let's go ahead and do that. Let's do our little distribution here. So 1/3 times 21 is 7x, and 1/3 times 18 is 6. Now on the the right side of my equation, I have 23, and then I have minus 2x, or 2 times x minus 5. Now I'm going to leave the 23, and then you have to ask yourself, okay, what am I distributing? Remember, we're distributing the number and the sign that's in front of the parentheses. So we're distributing a negative 2 to the x and the minus 5. So I'll have a minus 2x plus 10. Okay, now I'm going to check the left side of the equation to see if I have any like terms to combine together, and I don't. On the right side of the equation, oh, I have a 23 and a 10 that I can combine together. So 23 plus 10, that's going to be 33. So I'll have 33 minus 2x, and then I can bring down the 7x plus 6. Okay, so now again, I have to get all of my variables on one side and all of the numbers on the other side. So the smallest variable is this minus 2x, so I'm going to undo him by adding him to the other side. So that gets me a 9x plus 6 equals 33, because the 2 and the negative 2, they cancel. Okay, now again, you can think of this two ways. You can think of it as, oh, I just have a two-step equation to solve, or think of it like I have to finish getting all my numbers to the other side of the equation. So I have my variable on the left side, so that means I want to get rid of this plus 6. So I'm going to do the opposite of him. I'm going to subtract him over to the other side. So now the 9x is by himself, and 33 minus 6 is 27. Now to finish isolating the x, I have to undo that multiplication by 9, so I divide by 9. So those 9's cancel, and x equals 3. And again, we could check our work by taking 3 and substituting it back into the original problem and simplifying both sides of the equation and seeing if they're equal, just like I did on the previous example. So these are 3 really good examples, and they'll be just like the homework problems you're going to see in your homework. So keep these out as a guide so you know how to work through each problem step by step. Okay, our last example is just a word problem, and we're going to set up an equation first, and then we'll solve that equation. First, I want to read through the problem, make sure I understand it. So here we have a health club that has 2 payment plans. You can become a member by paying a $10 new member fee and use the gym for $5 per visit, or you can use the gym as a non-member for $7 per visit. So we're going to write an equation that represents the situation and then solve the equation. And we want to find out how many times you must use the gym to justify becoming a member. Okay, so most of our information that we need to write our equation is in those first 3 lines. Because right here where it says write, from that point on, it's telling us to write the equation and solve it. Okay, so a health club has 2 payment plans. Okay, so the first payment plan, you pay a $10 membership fee. So you pay $10, and so that and means plus we're going to do something else. We have to, every time we use the gym, we have to pay $5 per visit. So that's going to be 5 times V. $5 per visit. Per there means multiply. Or the other option we have is that you can use the gym as a non-member for $7 per visit. So that just means you go whenever you want. Every time you go, you just pay $7. So that's $7 per visit. So 7 times V. Now, there's plan A and there's plan B, and we're going to set them equal to each other. That's going to be our equation that we're going to use to solve for V. And when we find V, that'll tell us how many visits we have to make in order for us to make it worthwhile to become a member of the gym. Okay, so I have my variables on opposite sides of the equal sign, so I've got to get all my variables onto one side. Now the right side of the equation already has a V, and my left side of the equation has a V and a number. And 10 is my only number. So I'm going to leave the 10 there. I'm going to subtract the 5V over to the other side. That way in one step I can get my numbers on one side and my variables on the other side. And now I just have to divide by 2 so I can solve for V. So 5 equals V. Okay, so now we have to take a moment and we have to interpret what that means. Okay, that means at 5 visits, Plan A and Plan B would actually be the same amount. Okay, if I substituted the 5 back in, 5 times 5 would get me 25, and 10 plus 25 is 35. On the other side of the equation, I have 7 times 5. Well, that's 35. Okay, so that means that if you visit the gym 5 times as a member, it's the same as visiting it 5 times as a non-member. Okay, so in order for the plan to become cheaper, you have to visit more than 5 times. Once you visit that sixth time, being a member is going to be cheaper. Okay, and we can test that out. Let me switch colors here. We've got 10 plus 5 times 6. Let's just see what that does. Equals 7 times 6. Okay, so 5 times 6, that's 30. Plus 10, that's 40. But 7 times 6, that's 42. So look at that. Once you go to that 6th visit, then becoming a member is cheaper than if you just go as a non-member. So we would want to answer this question by saying, after 5 visits, it is more cost-effective to join the gym. And joining the gym means that you would become a member. Okay? So upon that 6th visit, it's cheaper to be a member. Okay, so again, remember when we're taking a look at these word problems, we're really practicing reading them and writing the equation and then solving the equation using the steps we practiced earlier and then interpreting the meaning, what that meaning really means, what that answer really is. Okay, so there's your homework for this evening. And make sure you show all your work. We're doing multiple steps in these problems, so make sure you write everything out. Mathematicians like to see all that work. But if you have any questions, come on in and see me before school.